So we're going to be solving problem number 1 from the first practice midterm. It says a PNP BJT with beta equal to 50 is found to conduct 1 microamp through the base where the potential difference between the base and the emitter is 0.725 volts. It asks to find the saturation current IS. And the problem also says to use the exponential model. And this is the exponential model for an NPN transistor that we're more familiar with. However, this problem says that it's a PNP BJT, so we have to, instead of VBE, we're going to use VEB because in a PNP transistor, the current flows from the emitter to the base. So we're going to use this equation, and then we can rearrange that to solve for IS, and we're going to get this equation. And then we're given IB, the current through the base. We're also given beta, and we're given VEB. So this equation uses IC, and from the BJT identities, we also know that IC is equal to beta times IB. So we can just plug in those values. Beta is 50 and IB is 1 microamp, and so we're going to get that IC is equal to 50 microamps. So then we can just plug that into the equation, and we're going to get that the saturation current is 1.27 times 10 to the negative 17 amps. And next, the problem asks, what current will flow through the emitter if the junction voltage is increased to 0.8 volts? So now we have this. So VEB is equal to 0.8 volts. We can use the same equation to solve for the different currents and then solve for IE by adding them. So using this, we're gonna plug in the saturation current that we now have, that we found in this part. So IC is equal to 1.27 times 10 to the negative 17 times E to the 0.8 divided by 0.025. This is the value of VT, this is VEB, and we're going to get that IC is equal to 1 milliamp. And then using this same identity, we're going to rearrange it to solve for IB, and we're going to get that IB is equal to 0.02 milliamps. And then we also have this BJT identity that the current through the emitter is equal to the current going through the collector plus the current going through the base. So we're going to add the current through the collector, which is 1 milliamps, plus the current through the base, which is 0.02 milliamps. We're going to get that the current through the emitter is 1.02 milliamps.